Hello and welcome to a new session on the topic architecture design patterns. Today's pattern is the anti-corruption layer. It's mentioned in the topic of domain driven design. Let's get started. In our use case, we are using a flight system and we have managed so far to refactor the monolith using a triangular pattern from the on-premise to the Azure cloud. To recap, let's review the architecture from the previous sessions. This is our starting point. We had the flight system and we had here a flights module. And this module was feeding the flight's information to the booking module so that a passenger or travel agent can book a flight. Moreover, we have refactored it using this triangular pattern so that we can see the communication between the booking service and the flight API using and the flight module using the flights API on premise, among other services that stayed on premise, and the security. That's the most important thing we want to highlight in our architecture design, is always security in mind. Moreover, we have reviewed some patterns so far, like command control, command query, responsibility segregation. We have reviewed the API gateway, and today's topic is the anti-corruption layer. An anti-corruption layer, it fits into the master data management topic when we have different identifiers from different systems and they are feeding into a global central system, and then the point is that we want to manage to unify, deduplicate, filter, and clean this data. So the anti-corruption layer here makes a lot of sense. In this architecture work package, we were tasked as an enterprise architect to design a target architecture to allow the flight service to aggregate the flight information from third-party providers, partner airlines, and this can fit also that our airline system has recently joined the Star Alliance, just a hypothetical example, and that means that they can also query the data from partnering flight systems and use them to be displayed and booked over their flight system. So a hypothetical example for transit, for many use cases and edge cases will arise. Let's focus now on the anti-corruption layer. So we are feeding the data from using the flight service is querying the data from flight APIs that are assigned to flight services on the third-party partner clouds. And moreover, to be able to query the data, it needs a JOT token for OAuth, and this means that it will query the OAuth server from both or more than two third-party clouds. Using the token, then it will start querying the flight APIs directly. The flight APIs deliver flight objects, and these flight objects now are the topic of our discussion. They consist of an identifier, ID, and they have many information about the flights, starting from traveling to start date and time, capacity, etc. There will be also a lot of topic about synchronization. When a flight is booked on our system, it needs also to be alerted and notified in the partner system. This could also be achieved using the command query response segregation. So we can, even here on the booking event, we can add one more subscriber to our booking Kafka topic. That would be the partnering reporting services from other parties. So just to see how flexible the patterns are and what we have gained from introducing the patterns into our design in front of the changing requirements or the evolving requirements. I'd like to say it is evolving over the time according to the business needs. Back to the anti-corruption layer. We have here two processes that need to be performed by the flight service. Actually, there are three because it first needs to authenticate, but this is part of the fetch flight. For the sake of simplicity, we focus on one more pattern here, the circuit breaker module. Let's say that one of the partner flight systems is down for maintenance or due to an incident. Whatever the reason, we cannot query the data from the flight APIs on the third-party cloud, one of the third-party clouds. So the circuit breaker system says, the circuit breaker pattern says, the client will query the API 3 to 5 times according how many retries you want to introduce, and then your system should continue to function reliably regardless of the fall of one or more components. So this is actually the function the circuit breaker module here will ensure, that even when the connectivity with any of the partnering flight APIs is down or not possible, the system will continue to function. This means that it will stop querying the APIs, it will use cached data, it will buffer the data to a, let's say, outbox table pattern, one of the patterns that we could also introduce in future sessions, and then try later when the connectivity is back up. This could be also be achieved. How do we know that the connectivity is back up? There could be also health checks. There will be a health endpoint, a health API on the partnering system so that we can check their status. This is also one of the possibilities, one of the patterns that are being used often, the health APIs. And then after fetching the flight information, we are expecting to be duplicate data, out of order data, outdated data, and we need to clean and filter and aggregate these data so that we can give the travel agent, or in the future also the passenger using the mobile application, the ability to book the flights with more information and insights on which flights are shorter routes to the destination and which are also from price are more worthy to be considered for the booking. So the anti-corruption layer is the layer introduced in domain-driven design that actually does this. It will be aggregating the data, giving the master data management here a universal ID, UUID for example, UUID for example, and this UUID then will be a primary key for the flight information, and using fuzzy matching or string matching, the flights can be matched together. So we know, for example, that the KLM, the British Airways, they are flying from London to Paris on Monday at 19 p.m. or 7 p.m. And that means that if we find similar information from more than one provider, they are more properly matching to the same flight, but using different IDs from different providers. So to avoid this hassle and to avoid this duplication of the information, unifying them using a universal ID from our central system would be exactly what the anti-corruption layer module means. So this example can be applied in many situations, not only to air flight systems. You can apply it to any master data management situations, for online shopping, for whatever use case you have at hand. I hope this pattern can also be handy for you in practice and you find it in your day-to-day architecture work quite useful. Thank you and see you in future sessions.